Cummins recommends the use of a positive flow deaerating cooling system containing a top tank with expansion area, fill line, vent line, and vent tube. This system aids in purging air from the cooling system during initial coolant fill and during operation. This system also provides a positive flow of coolant at the water pump during all engine operating conditions. Although the deaerating cooling system is used on most automotive applications, some light-duty applications, such as the pickup truck market, may utilize an open-top tank cooling system. In this section, we will look at the features and flow of the ISB engine cooling system. Select the section that you want to learn more about. In this section, we will look at various features of the ISB engine coolant system. Select the section you want to learn about. The ISB engine has an optional block heater located next to the oil cooler. The block heater provides for improved engine starting and operation during cold climate conditions. The integral thermostat housing, located in the cylinder head, provides a location for mounting the thermostat vertically in the cooling system. This orientation of the thermostat provides for better deaeration of the cooling system. The soft seal piloted thermostat controls the flow of coolant through the radiator and through the bypass passage to the water pump. The thermostat is equipped with 2 cage vent balls to help vent air from the cooling system. One of the features of the positive flow deaerating cooling system is in the way the system fills with coolant. Coolant is added to the reserve volume tank at a rate of 5 gallons per minute or less. This rate allows the coolant to flow through the fill tube and fill the cooling system. Coolant flows out of the reserve tank through the fill line to the engine and radiator. Flow from the fill line allows the engine and radiator to fill with coolant from the bottom of the system. As the system fills, the coolant pushes the air out of the system through the engine vent line and the radiator core vent tube. After filling the engine and radiator, coolant fills the reserve tank until the coolant level reaches the bottom of the fill neck. The position of the fill neck limits the amount of coolant in the reserve tank. This room in the tank not only leaves room for expansion, but also ensures that the radiator core vent tube remains open. The size and location of the vent line and radiator core vent are important to ensure proper venting of the cooling system. Coolant is circulated by the integrally mounted water pump. The water pump volute for the ISB engine has been redesigned to improve coolant flow. The water pump itself has been redesigned to enhance the flow of the coolant without the use of a water pump shroud. The output from the water pump empties into the oil cooler cavity of the cylinder block. This provides the oil cooler with the coolest possible coolant. The coolant then circulates around each cylinder. The head gasket is orificed to control coolant flow into the cylinder head. Coolant also flows from the right side of the block into the cylinder head lower coolant cavity, cooling the valve seat area. This coolant continues its flow into the upper cavity of the cylinder head. Coolant then flows up into the cylinder head, crosses over the valve bridges, and around the injector bore. The coolant then flows down the exhaust manifold side of the engine to the integral thermostat housing. When the engine is below operating temperature, the thermostat is closed, allowing the coolant to bypass the radiator and flow back to the water pump inlet through internal drillings in the cylinder head and block. When operating temperature is reached, the thermostat opens, blocking the bypass passage to the water pump and opening the outlet to the radiator. The engine must never be operated without a thermostat. Without a thermostat, the coolant recirculates, bypassing the radiator, causing the engine to overheat. With a positive flow de-aerating cooling system, water supply to the inlet side of the water pump is supplied from 3 sources: the bypass line, the bottom tank of the radiator, and from the fill line. When the thermostat is closed, the pressure in the block circuit causes the supply to the water pump to flow from the bypass tube. When the engine reaches operating temperature and the thermostat opens, the pressure in that part of the circuit causes the flow to come from the bottom tank of the radiator. The fill line ensures that there is a positive flow of coolant at the water pump inlet at all times. As the water pump increases in speed, more coolant is needed to increase the coolant flow. When the block and radiator circuit cannot supply enough coolant, the low pressure at the pump draws coolant through the fill line.